All right, welcome to day 4. Let's refresh a little bit here. What's the difference between these two things? Yeah. Good. This is a line segment, and this is a line. Because they're different things, we're going to use a different notation. When we write line segment, what do we put on top here? The line segment. When we write that it's a line, what do we put on top? A line with arrows, right? In other words, the picture matches what goes on top. Now, does the segment CD exist in this picture? Yes. It does. It's just from there over to there, isn't it? If I tell you that this AB segment is 4 inches long, and this CD segment is also 4 inches long, what do we know about these two things? Well done. You're using a fancy word that we haven't gotten to yet. But let me ask this. If you in this class right now are 15 years old, please raise your hand. Look at that. You guys are all identical because you're all 15. No, wait, that's not true. If you wear a size 8 shoe, raise your hand. Okay, how about a size 9 shoe? You guys don't have shoes? How about a size 7 shoe? Wow, it's weird. You guys have very different size shoes. But okay, let's say that the 3 of you have size 7 shoes. Are you guys identical because of that? No, that's ridiculous. How many different things would have to be the same so that 2 people are identical? Like, ridiculous number, right? Any of you twins? No? Okay. I have a friend who has twin boys. They're something other than identical twins. They're called chiral twins. You guys ever heard of this? They're opposites of each other. They're mirror images of each other. One has a little birthmark under his right ear. The other one has a copy of that birthmark that's reflected like a mirror under his left ear. One kid is right-handed, one kid is left-handed. Isn't that weird? I've never heard of that before. But even identical twins, do you have any friends who are identical twins? Are they truly identical? No. They laugh at different things. One of them might have scraped their face and so they got a little scar or something like that. It's really hard in real life to have things that are truly identical. So, yeah, because a recording image of this in front of the screen, never too long. What about these two things? Are these two things identical? They're certainly interchangeable, right? What are these things? Dry erase markers, Expo pens, chisel tip. And they're both the color blue. So they're both about the same height and they're both the same color and they're both the same function. Do they have the same weight? You don't know, do you? I'm going to come up here to the board and draw them. You tell me if you think they have the same weight. There's one of them. They don't have the same weight. What did you notice about the second one I drew? The line was much more faded. It has less ink in it because I used that one more. In real life, it's super hard to have things exactly the same. All measurements, all components exactly the same. This segment AB has how many measurable components? How thick is it? Remember, it's made up of points. Infinitely thin. How heavy is it? It doesn't have a weight. What color is it? It doesn't have a color. I'm representing it as green or blue or whatever. But the line segment itself doesn't have a weight, doesn't have a color, doesn't have a thickness. Does it have a length? Yes, it has a length of 4 inches. That's the only feature this thing has. What about this segment CD? How many measurements does it have? Just one, its length. It has no thickness, it has no weight, it has no color. Therefore, what can you say about these two objects, A, B, and CD? Are they identical in every measurable way that they have? Except their letters? They are. Because there's only one measurable element, we can say that A and B are beyond equal because the objects themselves are identical. This is a new term for us. It's called congruent. And what it means is exactly the same in every measurable way, except what we name it. And if in fact these objects are congruent, then we know that their measures, which in this case is just one measurable component, its length, is also equal. When I talk about measures, just numerically, they become equal. So this is a way that we express that things are the same size, or express their size, the measure of the segment. Because we use this concept often enough, we also have a shortcut notation, which is just the letters next to themselves with nothing on top. Now you're not talking about the object, you're talking about its size. All right. Here is a LaCroix. It is a 12-ounce can of soda. If I took another LaCroix, another 12-ounce can of soda, and for the intents of this discussion, let's pretend that this empty can I'm putting up here is now a full can of the same brand and model, etc. If I take the volume of soda, 12 ounces out of this, and 12 ounces out of this, and I add them, does that make 24 ounces? Sure, of course. If I take the weight of a full can of LaCroix and I add the weight of another full can of LaCroix, is that equal to the weight of 2 cans of LaCroix? Sure. If I took the amount of aluminum in this can and the amount of aluminum in this can, and I combined them, would the weight of those aluminums come together to form a larger number? Sure. If I add the price of one can and the price of another, will those two prices come together to form a larger price? Yes. But if I take the entire object and I take this entire object and I combine them, do they morph into a larger single object? No, there's still 2 cans. I can't like force them to be one can. For that reason, as we'll learn more about, when we do congruence, we can't add in the world of congruence. Like the fact that I take these 2 objects and I put them together, does it necessarily make a bigger, longer stick? It doesn't, the objects themselves. But if I tell you this is 5 inches and this is 5 inches, together, do their lengths add up to the same as one that's twice as long, or 10 inches? Whenever we're doing operations with these things, we want to use the equal sign because that's a number representation. Okay, let's see where this goes now. If we want to measure things, give it numerical values, we have to talk about that. Point A here and point B here, how far apart are they? Goes from -1 on the number line to 3 on the number line. 4 units long. How did you figure that out? I hear whispering, but I can't hear the answer. You counted, right? You went 1, 2, 3, 4. But what if I was at like -17 and 92? Would you want to be counting that up? Sounds brutal. So maybe there's a better way to do it. Turns out, if we want to measure the distance between A and B, all we have to do is take the value of the number at A, which we'll call lowercase a, and subtract the value of the number at B, lowercase b. So if we did -1 minus 3, we'd get -4. Minus 3, excuse me. That gives us absolute value of -4. We want that to be a positive number because distance is always measured in a positive form. So we put the absolute values on them to say that it's 4 units wide. I could also write that as just AB equals absolute value of A minus B. And again, like we talked about before, whether I use a capital letter or a lowercase letter makes a difference. Now we want to talk about congruent segments. If we know that we have 2 segments and their lengths are equal, AB is 4 units, CD is 4 units, they have the same lengths, then because that's the only measurable thing of a segment, I can say that these 2 segments, their objects, their things, are beyond equal, they're both congruent. So now I put the sign above the letters, AB with a segment on it, CD with a segment on it, and I put that little squiggly over the equal sign. I know it's weird because right now congruence doesn't mean any more than equal. It doesn't feel like you're getting any more value, but eventually it will. Now, remember when we talked about undefined terms and building a house? We want a strong foundation as much as possible, but sometimes you just got to start with things that are undefined. It's a little weak, but with just a couple of them, it's okay. In the same way, we're going to create a bunch of rules in geometry called theorems, but sometimes we won't be able to prove those rules and be confident in them, so we can't call them theorems. We have to call them postulates. And they're just like undefined terms. We're accepting them as true without proof. If I look at this picture, I have a segment from A to C with B in the middle somewhere. And if I tell you that this part is 2, and this whole thing is 10, could you tell me how big BC is? Yeah. Count of 3, please tell me how big you think BC is. I'll give you a second to calculate it. 1, 2, 3. Excellent. I didn't give you any rule for this, but you guys all know that when I've got AB next to BC combining to AC, what's true? The length of AB plus what? Good. The length of BC combines to make what? The length of AC. Excellent. And the fact that there's this point B in the middle doesn't cause a break in there because B is infinitely small, right? Doesn't have any size. So this plus this equals that every time. Do it again here. What's the equation I could write for this scenario? Yes, PQ plus QR equals PR. Everyone okay with that? Anybody not believe that that's true? I think we all accept that. That's why it's a postulate that we can accept, because it's so obvious, we don't need to prove it. It's dangerous. We don't want to do that a lot in geometry, but we're going to do it here. Now, if we said that PQ plus QR equals PR, and this problem is based on that, we can substitute. PQ is actually 9. So I'll replace PQ with 9. I'll replace QR with 28. And I'm looking for PR. So how long is PR? 37, right? 9 plus 28. Would you guys please do number 2? Please, please, please write out the letter formula first. And I want you to write that formula out in letters first, substitute, and solve. And on the count of 3, I want you to say the answer out loud, big and proud. 1, 2, 3. I heard two answers, 4 and 38. Agreed? Those are the two answers that were shared. One of them is totally right. The other one is you guys trying to skip steps, cut your work. So watch, I'm going to start off with PQ plus QR equals PR again. Now, last time we just added the two values up. So 17 and 21 makes 38. I could just jump to 38 if I'm not really paying attention. But this says find PQ. So we don't know what this value is. We're going to leave this as PQ. It gives us QR is 17. And it tells us that they together make up 21. So how do I get rid of a positive 17 and move it to the other side? Subtract it. Therefore, PQ is equal to 4. I know you guys have been doing algebra for like 2 years, basically, and it feels like you can just jump to the answers. Your teachers tell you to show your work, and you're like, yeah. I'm telling you that you will have dramatically more success in this work if you start off by writing the equations. So, for example, with this picture, what equation can I write? EF plus FG equals EG. Now, I'm going to tell you right now, if you don't write this and you try to jump steps, you will not get full credit on your homework. This is important, so do it. Now that I've written this formula, this is true. This is my rule. I can use deductive reasoning to plug in components that are also equal. How long is EF? 8x minus 17. How long is FG? 5x minus 3. How long is EG? Up here it tells us 71. Now I've got an algebraic equation that you should be able to solve. Because the equal sign is here, these terms are all on the same side. I'm going to combine like terms. I've got 8x's, another 5x's. That makes 13x's. I've got a negative 17 as a constant and a negative 3 as a constant. That means negative 20 or minus 20 as a constant equals 71. Now my goal is to get x all by itself. Right now I'm multiplying and subtracting. I'm going to go in reverse PEMDAS because I'm solving, and I'll take away the subtracting of 20. What's the opposite of subtracting 20? Good. So I'll add 20 to this side, which I'm allowed to do as long as I do what to the other side? Add 20 there as well. So I've got 13x equals 91. Now I don't want 13x's. I'm not greedy. I just want 1x. Right now, x is being multiplied by 13. So how do I do the opposite? Divide by 13. The 13 over 13 makes 1. That's what I want. That's 1x equals 91 over 13, which is 7. There's my answer. Any questions on how I did that process? Okay. We're going to do number 2 now. You're going to do this yourselves. Please, please, please start with the formula first. Use the letters first. Plug it in. Go. On the video, pause it while you do it. Okay, I'm going to interrupt you guys again and keep going on this. So how do I start? I'm just going to redo this one with you. What's my equation in variables, in letters? TU plus UV equals TV. TV is the biggest one, right? From the left point to the point kind of in this middle here, plus the middle to the right point makes the left all the way to the right. It's a visual thing. That's out of focus, okay? Even though we're looking for TU, it'd be nice if it was set equal to TU, but that's not the way this works. In this case, we know TU in terms of variables is 9x plus 2. How big is UV? 5. How big is TV? 14x minus 8. Now, these are on one side of an equation, so I can combine like terms. 9x plus 7 equals 14x minus 8. I'm going to bring my x's to the right, so I'll subtract 9x. And I'll add 18. And I'm left with 3 is equal to x. Is that right? Is 3 equal to x? Yes. Yeah. But is that the end of this question? No. Because it says find the length of TU. Well, up here, TU goes from there to there, and I know it's 9x plus 2. So I have a second step here. I have to say that TU is equal to 9x plus 2. And since x is 3, I can say that TU is equal to 9 times 3 plus 2. So 27 plus 2. TU is equal to 29. That's the end of my problem. And this is the work I expect to see. Now we're going to make mistakes in here, right? Please say you're going to make mistakes. That's how you know you're actually trying things out. I think you're going to make mistakes. One of the mistakes I think people made in some cases was they started off with the wrong formula. If you're looking for TU, wouldn't it be great if it said TU equals something? And that would be great. But you can't say that TU, this middle length segment, is equal to the small one plus the biggest one. That just doesn't make sense. You could write it. You could plug in the x values. You could come up with a solution and you'd have an answer. But that answer means nothing. Okay, please try number 5 yourselves now. Go. Okay. How are we feeling about this? 5 fingers. I feel good about this. 3. I'm making my way through it. I got some algebra gaps that can rear their ugly heads here, but I'll be all right. 1. I'm struggling with both the geometry and the algebra. Good. Good scores. All right, please flip the page over. And I'm going to teach you just one more fact, one more rule for today. And the good news is geometry is really kind of obvious about its words used. We're going to talk now about a midpoint. What do you think a midpoint means? Yeah, Elvis? Yeah, it's a point that's in the middle. So what would be the midpoint of this scenario? Okay. What's it in the middle of? Well, let's talk about these little marks. See these little marks here? Those are called hash marks. And when I put one mark on this segment and one mark on this segment, what I'm telling you is they have the same length. Or I could put 2 marks on both of them and say, since they both have 2, that means they're the same length. I could even put 3 on there, but once I put 3 on this and 2 on this, what am I telling you? They're not the same. I don't know what they are, but they're not the same. In this case, it started by telling us that those 2 parts are the same. If they're both the same, then that means B is the midpoint. So here's some notes on that. The midpoint of a segment is a point that divides the segment into what? Very good. 2 equal segments. And the thing that causes that midpoint, it could be a line like we've got here. It could be a ray. It could be a segment or even a point. But where it intersects and slices this line segment exactly in half is said to bisect that segment. And therefore, because it's the thing that bisects the segment, it's called a segment bisector. Is there such thing as a line bisector? Can you bisect a line? Why not? It's infinite. You don't have like equal halves on either side. They're both always equal, no matter where you put it. But in this diagram to the left, we're going to say that the point B lies right in the midpoint of segment AC. And how can I name this line? Good. I have to use the lowercase cursive L as a standalone letter. I can't say like BL. There aren't 2 points to name it by. I have to call it line L. And line L is our segment bisector. Of segment AC. By itself, this doesn't seem all that difficult. Let's go down to problem 8 here. A few minutes ago, we were working with the rule that said, I know that PQ plus QR equals PR. Is that true for this picture? It's totally true. It doesn't help us at all. I've got PQ information. I've got QR information. I don't have any information on PR. Oh, wait a minute. But it tells us that it's the midpoint. Therefore, if it's a midpoint, it cuts it into 2 equal segments. So that means that this equation doesn't help us, but PQ equals what? QR. And with that information, I can say that 7x minus 16 equals 4x plus 2. Subtract 4x. Add 16. Divide by 3. X equals 6. Am I done? Or do I have more to do? It says find the value of x. Did we find the value of x? Yep, we're done with that one. Please do number 9 yourselves now. Go. Hey, how are we doing on that? We set up the midpoint idea, substituted and solved. We got x equals 3 again. This time it asks us to find GH. So GH is 5x plus 2. Since x is now 3, we can put in a 3 instead of x. 5 times 3 is 15, plus 2 is 17. Feeling okay about this? Any questions? Segment addition postulate is easy. You said so. Midpoint is easy. But sometimes it gets a little harder. Let's take a look at number 11. We're supposed to find y. I've got one expression that has y in it. This has y in it, right? These don't have any y's in it. So do you agree that I have to use FH somehow? Because that's where I get my y. If I'm going to solve for y, I got to get FH involved. So I'm going to have an equation with FH in it. Can you think of an equation that involves FH? Is it midpoint or is it segment addition postulate? Anyone? Anyone? Bueller? Which equation would let us say is equal to FH? The segment addition, right? FG plus GH equals FH. Okay, let's try that. 4x plus 3 plus 7x minus 12 equals 6y minus 2. Let's combine like terms because we can. 4x and 7x is 11x. Positive 3 and negative 12 is negative 9. Now I could solve this for y, or I could solve this for x, but it won't come out easy or clean or anything. Can I find what y equals using this equation? Or asked a different way, how many solutions are there to an equation that has two variables in it? You spent a lot of time last year with y equals mx plus b, didn't you? How many solutions are there to y equals 2x plus 3? Go off on a little tangent here for a second. Y equals 2x plus 3. How many solutions are there to this problem? Infinite. So much so that we graph it as a way of showing the solutions. Every point along here works. 0, 3 works. If I put 0 in for x, the y value is 3. 1, 5 works. If I put 1 in for x, the y value is 5. 2, 7 works. If I put 2 in for x, the y value is 7. So when I have two variables, I can't possibly solve it. Unless, do you remember systems of equations where you put two equations together to solve? Find a POI. So I've got to somehow solve for x in here so that my y can be solved. Oh, it tells me that it's a midpoint. What does that mean? What equation can I start with now? Because it's a midpoint. Good. FG is equal to GH. So 4x plus 3 is equal to 7x minus 12. Minus 3x equals minus 15. X equals 5. Oh, and now I can use this equation over here. I know that 11 times whatever x is minus 9 is equal to 6y minus 2. And I just found that x is equal to 5. So 55 minus 9 equals 6x minus 2. 46 equals 6y minus 2. Add 2. 48 equals 6y. Divide by 6, divide by 6. Y is 8. Does it still use the same knowledge? Segment addition postulate and midpoint. It does, but it's going to ask you to do a little bit more problem solving. You'll find that your homework today is not only to finish this first page we started and the second page, but there's 2 more pages of it. These 4 pages are considered your homework number 4. You may have the rest of the period to work on this, which is 40 minutes. You can probably come really close to finishing it all by then. Raise your hand if you need some help.